Hello friends and welcome to YouTube channel Freedom Tech, and in this session what we are going to learn. In this session we are going to install latest object detection method which is yolo11 on Raspberry Pi bookworm 64-bit version. Also we are going to create our own custom object detection model. We are going to create our own custom segmentation model. Also we are going to use here a Raspberry Pi 4 camera module for object detection purpose. So before we move to our practical friends, if you learn something from our videos, please consider to subscribe our channel. Okay friends, thank you so much and let's get started. So friends, as I mentioned, Ultralytics yolo11 is just released and today we will install on Raspberry Pi 4 yolo11. Also we are going to create our own custom object detection model, custom segmentation model, and here we will use Raspberry Pi 4 camera module for object detection and segmentation purpose. Simple. So for that I have created a new repository. I will mention the link. You need to simply copy paste the link inside the web browser. rpicam yolo11. Just go to the code, click on download zip, and it will download our zip format repository. We successfully download our repository. Then just go to the file manager and then go to the downloads. This is what our repository. Right click and then we will extract our repository as a folder. So as you can see, it's extracted. Now we want to move our folder, or we can say repository, inside our home folder. So right click, just right click, cut, go to the home and then just paste it here, paste. So this is what our repository is. So let's just go inside our repository, and here we have rpi bookworm txt file, which is text file. So right click to the file, open as a text editor. It will open our file as a text editor. Then the first command, sudo rm space usrlib python 3.11, just copy as it is, just copy it, open terminal, and then just paste the command inside our terminal and then just hit enter. Done. So now we successfully run this command. It means now we can install packages with the help of pip command. Done. So here first we will install our OpenCV package. So let's just go to the menu. Remember one thing friends, this is completely fresh version of bookworm 64-bit version. So go to the menu, programming, and then open Thony Python IDE. So it will open our Thony Python IDE. So this is completely fresh version. So I need to just click on switch regular mode. So click on switch regular mode, click on OK, then close. Again go to the menu, programming, and Thony. It will open our Thony as a regular mode. Here it is, as you can see, 3.11.2. Now go to the tools, manage packages, and search for OpenCV-Python. OpenCV-Python, hit enter. It will search for OpenCV-Python. Select the package, and then we will see here install tab. So here it is, as you can see, install button or install tab. Just select it, click on it, and then it will install OpenCV on our bookworm 64-bit version. So friends, we successfully install OpenCV-Python. Here we will click on upgrade button. So if there is a upgrade, it will automatically upgrade our OpenCV package. Done. So now we will search for Ultralytics package. So Ultralytics, and then hit enter. First package, click on it, and then click on install button. It will install Ultralytics on our bookworm 64-bit version. So friends, we successfully install Ultralytics package. Now just click on upgrade button and we will cross check if there is any upgrade for Ultralytics. So friends, done. Now we will install our next package. Click on CVzone. Just search for CVzone package. Click on search on PyPy, CVzone, install. Now it will install CVzone. So friends, we successfully installed CVzone also. Now let's just close all these things, and here we will first cross check if we successfully install our packages. So for that we will import the packages. So import CV2, hit enter. There is no error. Then we will call YOLO from Ultralytics. So from Ultralytics lytics, from ultralytics import yolo and then hit enter. So friends, as you can see, there is no error for yolo also. We successfully import yolo from ultralytics package. Now let's just run our file. So go to the file, click on open, then go to the home and our folder. Inside that we have our yolo11 object detection track.py. So just click on the code and click on OK. It will open our code like this way. Import CV2, import pycamera2, import pycamera2. This is what our modules. And then here we will use yolo11n.pt because we are right now on our Raspberry Pi 4. So we will use nano model. So yolo11n.pt, then CV2.cap video capture 0. 0 is basically our Raspberry Pi 4 camera module. And then main thing is imgsz, image size 240 for Raspberry Pi 4, 240 image size. And then this is the basic method. Then we have rectangle, then we will put the track ID on the frame, and then we will put the classes, class name. Simple. So let's just start our code. So friends, as you can see, it's downloading our model. And then friends, as you can see, this is what our detection. It's detecting me as a person. And it's little bit slow because right now I am recording on same Raspberry Pi 4, so it will take some time, but without recording it will work really fast. And this is what our mobile, cell phone. As you can see, it's detecting cell phone also, person and cell phone. So we successfully detect object with the help of latest yolo11. Simple, on Raspberry Pi 4 64-bit version. Just stop the code and now we will open our segmentation method. So go to the file, click on open, and then we have yolo11 sec-track.py, click on OK. And this is what our segmentation code. From segmentation also yolo11 nsec.pt, and this is what our pycamera, as you can see, pycam2. So it's basically calling our Raspberry Pi 4 camera module. Also, if you don't know how to connect or how to configure the camera module, I have already created the video. Watch video and connect the camera module with the Raspberry Pi 4. Done. So same way, let's just start our code. So friends, as you can see, it's downloading our yolo11 nsec.pt, and here also we want to mention image size 240 for Raspberry Pi 4. And friends, as you can see, this is what our segmentation. And then we have our cell phone. As you can see, it's detecting our cell phone also. Simple. So we successfully configure yolo segmentation also. So we're done with default yolo segmentation and default yolo object detection for yolo11. Now we will create our own custom object detection model. Also we will create our own custom segmentation model. So for that we need images. So for images, go to the file, click on open. We have your img.py, just open img.py, and we will collect the images with the help of Raspberry Pi 4 camera module. So let's just open our repository, and here we will create a folder, and folder name is basically images. Images. This is the images for object detection, and let's just create images 1 folder, images 1 for segmentation. So now we will first create object detection custom model. So this is the images folder. Let's just right click and copy the path, and here cv2.imwrite from images, just remove back and press Ctrl+V. It will paste our new images folder path. So home rpycam yolo11 main, then images folder, and here we want to mention our image name which we are going to capture. So here I will capture parachute oil bottle. Also I have here a Colin bottle which we are going to detect. This is what our custom object. So let's just start with Colin. So I will mention here Colin Simple. And save the code. Now I will start the code, and when I will move the calling cleaner bottle in front of Raspberry Pi 4 camera module in different angle, and it will capture the images. So 30 images is more than enough, or let's just go with 40 images. So I will mention here 40 images, and it will capture a calling bottle 40 images and parachute hair oil bottle 40 images. Simple. So let's just start our code. So friends, here what I will do, I will just mention over here, let's just say time.sleep, because it is really fast, so I will mention 0.01, and let's just delete the images which we just capture, Ctrl+A and delete. Now again I will start the code. Okay, now it's good. Simple. So we capture 40 images of calling bottle. So if I open our repository and images folder, and if I right click with image viewer, and then as you can see, this is what our calling bottle images which we just capture. So for demo purpose, 40 images is more than enough. So in real scenario you need more images. So now here I will mention our next class name, which is parachute parachute. Simple. Now save the code, and if I run the code, done. So we capture parachute bottle images also. I open our repository and then images, right click, open with image viewer. So we have calling bottle images, we have parachute bottle images, as you can see. Done. So we're done with our data. We have now our images. Now we need a label img software. So how to install label img on latest bookworm? So for that, again I mentioned the method inside our repository. So let me close the text file, and then we have here another text file, label img.sh. So here what we will do, friends, we will run this bash script, this one, and it will automatic install label img. So let's just open our terminal, and here I will run the ls command, and this is what our repository, as you can see, this is what our repository, rpycam yolo11-main. Let's just go inside the repository. For that we are going to run the command cd space rpy-cam yolo11-main, and then just hit enter. If I run ls command, and our script, bash script, is this one. Now we want to first mention full permission for label img.sh bash script. So run the command like this way: sudo space chmod sudo space chmod 775 space label img.sh. This is the command. Sudo space chmod space 775 space bash script name, which we want to mention as a full permission, label img.sh. Simple. Then just enter. Now if I run ls command, as you can see, the script is now green, means we successfully mentioned the full permission. Now we are ready, and we will run the code, means our bash script. So bash space label img bash space label img.sh, and then just hit enter. It will install label img software. So friends, we successfully installed label img. As you can see, the message successfully installed label img. Now we are ready, and let's just clear the screen and run the cd command. Come out from our repository, our folder, again clear the screen, and here if I run the command like this way, labe, and just press tab button. So LABE and press tab button, it will auto complete our label img command, and then just hit enter. It will open our label img software. As you can see, as I mentioned, it's open our label img software. Now make like this way, and then just click on open dir, go to the repository where we have our images folder. Inside that we have our all images for this project, and then this is what our first image. Change save dir, again same repository, go to the images, just click on choose, done. Now we are ready, and here we will select YOLO. So Pascal VOC is by default there, as you can see. Now just click on it and it will change with YOLO. Create rectangle box and just draw the rectangle box on our object like this way, and mention the class name. So Colin is the class name. This is the Colin bottle. Okay, save it. If I open the repository inside images, you will see the image and their file, text file. Inside that text file we have rectangle coordinates. Right click, and if you open with text editor, as you can see, this is what our rectangle coordinates. Simple. So this is how I will draw a rectangle box on all Colin bottle images. So friends, we have done with Colin bottle. So this is what our parachute hair oil. As you can see, just click on create rectangle box, and I will draw the rectangle box on the bottle, and then I will mention the class parachute. That's it. Then click on OK, save it, go for next image, create rectangle box, draw the rectangle box on parachute hair bottle, then parachute is the class name, click on OK, just save it, go for next image, create rectangle box and just draw the rectangle box on it like this way, click on OK, save it. So let me draw the rectangle box on parachute hair bottle. So friends, we are done. This is what our last image. Now we have successfully draw a rectangle on each image for each class with the help of label img software, for Colin class and for parachute hair bottle class. Done. Just close label img software. Now minimize terminal and open our repository. So our repository rpycam yolo11 main, and if you go inside images folder, we have image, their txt file, image, their txt file. Simple. For parachute also image, their text file, image, their text file. Done. Now go back, and here we will create a freedom tech folder. So let's just say freedom tech. This is what our folder name. Click on OK, and inside that freedom tech, go inside freedom tech folder, and here we will create images and labels folder. So let's just create images, and next one labels folder, images and labels. Now go inside images folder, and here again we will create training and validation folder, training and validation. Done. Go back, go to the labels folder, go to the labels folder, and then again here we will create training and validation folder, training validation. Done. Now simply we will copy all the images and their text file from images. So just Ctrl+A, right click, copy, and then we will go inside freedom tech folder, images folder, training folder, and paste it here. Then go back for validation, same way, just paste it all the data. Go back, labels, training, paste it data, same way, validation, paste data. So this is how you need to copy paste all the data from images to freedom tech, images, then training, and then validation. Then same way for labels, training, all the data, and validation, all the data. Simple. Now we will create a zip file of our freedom tech folder. So again open terminal. Let me clear the screen. So just clear the screen, and then again we will go inside our repository. So our repository name is, if I run the ls command, rpycam, so cd rpy hyphen and then press tab button, it will auto complete our repository ls command. And here we will run the command zip command on freedom tech folder. Here it is, as you can see, this is what our freedom tech folder. So command is what? sudo space zip space -r, sudo space zip space -r, then again space, and then here we will mention the file which we want to create. So our file name is freedomtech.zip. So freedomtech.zip, this is what our file name, then space, and then we will mention the folder which we want to create as a zip file. So our folder name is freedomtech, and then we will mention here, because we want to zip all the data from freedomtech folder, so slash and star, it will be zip all the data from freedomtech folder, and then hit enter. As you can see, it's creating zip file with all the data. Done. So minimize all these things, and here we have our freedomtech.zip, as you can see. Now this freedomtech.zip we will upload on our Google Drive. So let me open my Google Drive. So friends, I have opened my Google Drive. You need to simply open your Google Drive, then click on new, file upload, and then go to the home, our repository, and our freedomtech.zip file, this one. Select it and click on open. It will upload our freedomtech.zip on Google Drive. As you can see, uploading item, one item. Now meanwhile we will open our Colab machine. So I have opened the Colab machine, and I will upload the Colab file, our training file, on Google Colab machine. So just click on upload, go to the browse, then go to the home, repository, and first we will create object detection model. So select rpy yolo11 object detection on custom dataset file, click on open. It will upload our Colab file. So friends, this is what our Colab file. Now let's just start our GPU. So go to the runtime, change runtime type, select Python 3 and select T4 GPU, then click on save button, and then just click on connect button. So we successfully connected. Now let's just run our cell one by one. So first cell, click on it. Next cell, it will install Ultralytics package. Done, we install Ultralytics package. Now import the packages which we install: Ultralytics, ipython.display, import display image. Done. Now we will cross check if Ultralytics is successfully installed or not. So for that, as I mentioned, this is what Raspberry Pi 4. So I will use here yolo11 nano model. So run the next cell, it will download our yolo11 nano model, and then it will run the model on the image from RoboFlow, which is the doc.jpeg. Done. So person, car, dog, and handbag, it means we successfully detect the object. It means we successfully install our yolo11, or we can say the Ultralytics, on Google Colab machine. Now we will mount our Google Drive. So let's just first cross check our upload is completed. Yes, our upload is completed, and now we will mount our Google Drive. So click on next cell. Then permit this notebook to access your Google Drive files. Just click on connect to Google Drive. And here you need to select your Gmail ID. So just select it. Then click on continue. Then here just scroll down, click on again continue. Now it's mounting our Google Drive. So friends, we successfully mount our Google Drive. Now let's just unzip our freedomtech.zip. So it will create dataset folder, and inside that it will unzip our freedomtech.zip. So let's just run our next cell. Done. So if I click on this folder icon, here it is. As you can see, we have dataset folder, and inside that we have freedom tech folder, and then we have images and labels folder. Now here we will create a data.yaml file. So just click on this three dot and then click on new file, mention the name data.yaml, then I mistakenly mentioned the wrong name, so let me rename the name, rename file data and hit enter. Data.yaml, double click the file, it will open our empty file like this way. Simple. Now inside that repository I have mentioned data.txt file. Just open data.txt as a text editor like this way, and then copy the code, copy as it is, close all these things, and then paste the code inside our data.yaml file. Here you need to select allow, then it will paste our code. Now here of course we want to mention our class name, so we have two classes. So first one is our Colin bottle, so Colin, then comma, in single quote we will mention parachute bottle, parachute. Then now simply press Ctrl plus S from the keyboard and close the data.yaml. We have done, and now we will start our model creating process. So yolo11 n.pt, content dataset freedom tech, where we have data.yaml epoch 100, and because as I mentioned we are on Raspberry Pi 4, so image size is basically 240. Now let's just run our cell. So friends, here it is. As you can see, we have some error, content dataset freedom tech images training does not exist. So let me check here, images, and as you can see friends, there is a typo mistake in this folder, training folder. So I will rename the folder again. So double click and rename folder training, okay, training. Now it's good. Now it will start our process. So again let me start the code. Scroll down. Now there is no error. And as you can see, it started our training process. It started epochs 1 out of 100. So it will take some time. Meanwhile, I will pause video. So friends, as you can see, our training is completed and our model is saved inside runs, detect and train 2. So just click on this folder icon. Then we have runs, we have detect, we have train 2, and then inside that we have weights. And then we have our base.pt. Just click on this three dot and click on download. It will download our base.pt model. As you can see, we successfully download our model. So minimize all these things. Open file manager, downloads, base.pt model. Right click, cut, home, our repository, and the model, just paste it here. Done. Now let's just open our file. Go to the file, click on open, and go to the home, repository, and yolo11 object detection and track.py. Click on OK, and here we will mention our model name, which is base.pt. Also we want to create our custom label file, which is coco1.txt, but first let's just check what is the frequency of our labels. So first is Colin, and then we have parachute. So here, new file inside repository coco1.txt, create the text file, mention the name coco1.txt, and then coco1.txt, right click, open as a text editor like this way. This is what our text editor. We open coco1.txt and we will mention here our label name. So first is Colin and then parachute. parachute hair oil. Simple. Click on file, click on save, close all these things, close it and minimize browser. Now we are ready, and here we will mention our coco1.txt file. Now let's just run our code. And friends, as you can see, we started our camera module, and if I show the Colin bottle, and as you can see, it's detecting Colin bottle. The class name is Colin, rectangle and the bottle. Now I will show the parachute hair oil bottle. As you can see, it's detecting parachute hair oil bottle also. So friends, as I mentioned, because right now I am recording on same Raspberry Pi 4, and my Raspberry Pi 4 is basically 4 GB, but without recording it will work really fast. So now we have done with custom object detection. Now we will create custom segmentation. So for that, again same object we will train. So let me mention here images 1, and I will create same way images for Colin and for parachute bottle. So let me create the images first. So friends, same way I have captured the images for our segmentation. So if I open file manager, repository, and images 1 folder, and here it is. As you can see, we have Colin images, 40 Colin and 40 parachute. Now for annotation we will use RoboFlow. So just open RoboFlow. So friends, I have opened RoboFlow. Click on sign in button and just sign in with your Gmail ID. So I have already signed in. So friends, it will open this kind of dashboard. Click on new project. We will create a new project, and here I will mention the name RPi4 segment, RPi4 segment, and then I will mention here a class name. I will mention the class name. So Colin is the class name, and then RPi4 segment is the project name, and visibility you can go with public. I will just stay with private, and here I will select instant segmentation and then click on create private project. Now here we want to select our folder, so click on select folder. Then go to the home and our repository. Inside that we have images 1, where we have all our images. So select it and click on upload, and here we want to mention the permission. So click on upload again. So friends, as you can see, we successfully upload all our images. Click on save and continue. And then friends, we will see this kind of dashboard where we have all our images. So here we will select last option, start manual labeling. So just select the start manual labeling, and then here we want to select assign to myself. So just click on assign to myself, and then click on start annotating. Then here, welcome to RoboFlow annotation editor. Just click on close. Or let's just click on get started. So now this is what our dashboard, or we can say this is what our page where we are going to start our annotation. So let me delete here. Click on delete, and we will select the bounding box tool and draw the rectangle box on our bottle, a Colin bottle, like this way. Draw it, and then right click and select the first option, convert to smart polygon. Just select it. It will convert our bounding box into polygon. And then because we already mentioned the class name, one of our class name, which is the Colin, so there is no need to mention the class name. Just click on save, and it will save our image as a segmentation, because we change here bounding box tool as a smart polygon. Simple. and then go for next image same way. So now friends, here we have our parachute bottle. So same way, draw the rectangle box, draw the bounding box on parachute bottle, then right click, click on convert to smart polygon, and here we will create a new class which is parachute bottle. So just mention the new class name parachute bottle, and just click on create class. It will create our new class which is parachute bottle, parachute. Then now go for next image same way. Again we have here our Colin bottle, so draw the bounding box, right click, convert to smart polygon, and then we will select a calling class and then save it. Then go for next image. Again we have parachute bottle, same way, draw the bounding box on bottle, right click, convert to smart polygon, and select the parachute class. So this is how I will draw the smart polygon on each class, on each bottle, for Colin and for parachute bottle. So friends, we successfully completed our annotation process. This is what our last image, parachute. Now just click on project name R54 segment, just click on it, and then click on add 80 images to dataset. So click on add 80 images to dataset, then click on add images, done. We have completed our annotation process. Now just click on generate tab, here generate, then click on continue, click on continue, then click on create. It will create our data set. Done. As you can see, you will see this kind of page. Now here we will open our Google Colab file. So friends, I have opened Google Colab. Just click on upload, click on browse, then go to the home, our repository, and inside that we have yolo11 segmentation on custom datasets. Just select the file, click on open. So we successfully upload our file. Here we will select GPU, so click on runtime, change runtime type, select Python 3, select T4 GPU, click on save, and then click on connect. So friends, we successfully connected. Now let's just run our cell one by one. So first cell, then next cell, pip install Ultralytics, it will install Ultralytics. Done. We install Ultralytics package. Now let's just import our packages. From Ultralytics import YOLO, and from IPython import display and image. Done. Now again same way we will cross check if we successfully install Ultralytics or not. So yolo11n-sec.pt is the model, and then image which is the same doc.jpeg from RoboFlow. Done. As you can see, person dog, so it means we successfully install Ultralytics and we have our yolo11 ready. Now here we will now call our RoboFlow dataset. So just open our page, here click on download dataset, and then we will select a format which is the latest one, which is yolo11, select it, and then click on show download code option, select it and click on continue. Then we will copy paste all the code from, just copy paste from and open Colab machine, and here from just select all the things and delete it, then press Ctrl+V, it will paste our new code. Here it is, as you can see, yolo11. Now just run the cell. Done. So now if you click on this folder icon, we have here our dataset folder. Inside that we have RPy4 segment, our project name, and then we have test train valid, and we have data.yml. Just double click on data.yml file. and here we will change the train and valid and test path. So first is train, so train, just click on this three dot, copy path and remove the old path from train, remove it and then press Ctrl plus V. Same way val, so valid, go here, three dot, copy path, come over here and remove the path, then Ctrl plus V. Then test folder, select the test folder, three dot, copy path, test, remove the old path and Ctrl plus V. It will paste our path. Now we have done, and we have our class already there, Colin and parachute bottle. Now simple, press Ctrl plus S, it will save our file data.yml. Now we are ready and we will start our training. So yolo11 sec.pt, and here we want to mention our data.yml path. So data.yml, select it, three dot, copy the path and then from data.yml remove all the things, remove all the things, do not delete data, okay, data name, and then press Ctrl plus V. It will paste our data.yml path and then epox 100, and of course because we are on Raspberry Pi 4, so image size is 240. Simple. Now we will start our training. So friends, as you can see, our training is started, 1 out of 100, so it will take some time. Meanwhile I will pause the video. So friends, our training is completed and our model is saved inside runs segment train. So runs segment train weights and base.pt. Just click on this three dot and download the model. So friends, we successfully download our model. Minimize all these things and open file manager, go to the downloads, and this is what our model. But first, because we already have base.pt model for our object detection, so let's just rename it best, let's just say best1.pt. This is what our object detection model, and now we will go inside downloads, we will cut the base.pt, cut, go to the home, our repository, and just paste it. This is what our segmentation model. Done. And now let's just open our coco1.txt with the text editor, and let's just check the label or the names, class names frequency. We have a first Colin and then parachute, all is same, all is good. So now let's just close the text file and close all these things, and we will open our segment file again. Go to the open, home, repository, and yolo11 sec.track.py. Here we will mention coco1.txt, and yolo11 sec.pt. we will mention our model name, which is best.pt, and all is same. There is no need to change anything, and let's just run our code. So friends, our camera is started. This is what our frame, and if I show the Colin bottle to Raspberry Pi 4 camera module, and as you can see, it detected Colin. There is a polygon, there is a mask, and there is a green color rectangle, and Colin is the class name on top left rectangle. And then I will show the parachute hair oil bottle. Here it is, as you can see, it's detecting parachute bottle also. We have our mask, we have our rectangle, we have our class name. That's it. It means we successfully create our object detection custom model, our segmentation custom model, and we detect our custom object. So I have mentioned full code. I hope you will learn something from this video. We will meet our next video. Till then, thank you, take care, and bye bye.